Hi everyone, welcome back to my tutorials. I'd like to do a video on altitude on hypotenuse formulas. So we can use similar triangles um, to write triangles to derive some interesting formulas. So before I start my video, I want to apologize in advance if you hear some background noise. It's not the 4th of July, but people are already setting off fireworks, so that might, create some background disturbance, but I've turned on my fans, so hopefully it won't interfere too much. But let's just get started with this video. Theorem 1, the altitude-hypothenuse theorem. We're given the angle BAD, this angle here, ACB, this angle here, and ACD, this angle here, are right angles. We want to prove that AD squared is equal to DB times DC. AB squared is equal to BD times CB, and AC squared is equal to BC times DC. So remember, we're dealing with lengths here, right? So DB means the length of segment DB. So let's start off, write down what we're given, and we know this, right? I'm going to use the reflexive property of congruence, and angle D is congruent to itself. So then I can use the angle-angle theorem for similar triangles to derive triangle ADB is similar to triangle CDA, right? Because A is a right angle and C is a right angle over here, and they share this common angle D. So we know these two triangles are similar. We know in similar triangles, lengths of corresponding sides are proportional, so I can just literally read it off according to the order of the letters, right? So AD divided by CD equals DB divided by DA. Once again, these are lengths, right? So if I cross multiply, well, the length of segment AD is equal to the length of segment DA, right? It doesn't matter because lengths are going to remain the same no matter which direction you measure it, right, on the segment. So we end up with AD squared is equal to DB times DC, and I'll just put down we used algebra, we cross multiplied, right? So that gives us our first property. So now we're going to continue. In similar triangles, corresponding angles are congruent, and we're using this similarity relation up here, right? So we know that angle ABD is congruent to angle CAD. So like I said, you can just literally read it off, right? So ABD CAD, the ordering is going to be similar, right? So what is ABD? Well, ABD is angle 1, right? And CAD is angle 2. So in other words, angle 1 is congruent to angle 2 by substitution. We can use the reflexive property of congruence. Angle 1 is congruent to itself. And then we can use the angle-angle theorem to show that triangle ABD is similar to triangle CBA. So we know in similar triangles, lengths of corresponding sides are proportional. So AB divided by CB equals BD divided by BA. So length of side AB and length of side BA are the same thing, right? So if we cross multiply, we get AB squared equals BD times CB, which is property 2 here. And then we can do the angle-angle postulate with 1, which is the right angles, right? And using the fact that angle 1 is congruent to angle 2. And then we get triangle ABC is similar to triangle DAC. And then we just AC divided by DC equals BC divided by AC. Because in similar triangles, lengths of corresponding sides are proportional. and then we can do some algebra. We get AC squared is equal to BC times DC. So this will be some formulas we can use to solve triangles. So we're given that BAD, BCA, and ACD are right angles. We're given that AD is equal to 4 and BC is equal to 6. Find CD and AC. So this is a computational problem, so write down what we're given. We know that length of BD is equal to length of BC plus the length of CD. I'm going to apply the Altitude-Hypothenuse theorem to get AD squared is equal to BD times CD. So I just go back and then use whichever one of these formulas corresponds in triangle, right? And then I can substitute what I have in 3. So BD is equal to BC plus CD into this BD over here. So and then we could substitute values, right? So we get this equation here by algebra, right? And we can factor this equation as CD minus 2 times CD plus 8 equals 0. So that only leaves CD is equal to 2, because CD minus 8 can't happen because lengths are always positive, right? So we can throw out that extraneous solution. To find AC, we can use one of the Altitude-Hypothenuse theorem properties, right? And get AC squared is equal to BC times DC. And we can just substitute what we have in statement 2 and use the fact that CD is equal to 2, therefore DC is also going to be equal to 2, right? We get AC squared is equal to 12, and then I take the square root. AC is equal to root of 12. So this is going to be the second and last problem. I know this is a short tutorial, but you know, I wanted you to see this because it'll be useful when we do some other properties in the future. So we're given BAD, BCA, and ACD are right triangles, and we want to prove that BA times AD equals AC times BD. So this is a right triangle, right? So in other words, altitude times hypotenuse is equal to side times side. That's what we're trying to prove. So I'll write down what we know, and we're going to use the fact that angle B is congruent to itself by the reflexive property congruence. By the angle-angle theorem, triangle CBA is similar to triangle ABD, and in similar triangles, lengths of corresponding sides are proportional, so we get BA divided by BD equals CA divided by AD. Once again, you just look at the ordering between the two triangles and of the letters, and they should line up, right? And then you can cross multiply. I'll just put algebra applied to this, and we get BA times AD equals BD times CA. And remember, these are lengths. So that's pretty much all I have for you in this video. I want to thank you for watching, and I hope to see you during my next video. All right, have a good night, everyone.